So in the previous video, we actually discussed about how to derive the forward rectangular Euler's forward what is that called, low pass filter, right? We actually came all the way to somewhat prove to you that, you see, your this thing over here, your low pass filter is A over S plus A, is this thing over here in the Z domain. Okay, and then we also say that for the forward, backward, or trapezoidal, your just after your integration, this particular point, right over here, somewhat is in terms of some words. Later on I'll just tell you. Alright, so just after this particular step, the next step is the point where this particular one step is the most critical one, because the rest will just be another form of rearrangement. Okay, only this particular step itself determines whether are you a forward, are you a backward, or are you a trapezoidal one. Trapezoidal can be twisting, can be bilinear. The name for trapezoidal can be many names. Like trapezoidal can be bilinear or twisting. They're all the same. They're called trapezoidal. But anyway, in this case, in this video, I'm gonna explain to you what do we sub in over here, this critical step. Alright, so this critical step over here is gonna reference to this particular step. You see, as you can see, this is the particular step where this is talking about your integration part. Well, this particular point where you're gonna integrate, after you integrate, it becomes like this. So maybe I should choose a different color. So this thing over here is this thing, while this thing over here is this thing. Alright, this is for the forward. Alright, just to show you, this is for the forward. So your forward is UKT minus T. Alright, plus, alright, and then this thing is standard for all the trapezoid, for all the methods. Alright, this particular first term is standard throughout, so it's UKT minus T. If you take a look for the backward, this is also UKT minus T. Alright, this is for your backward. Okay, and then if it's for the trapezoidal, this is also UKT minus T. You see, so the first term over here is always UKT minus T. However, the only variations is only at this particular second term, which the magic comes from where? Alright, the magic comes from here. Alright, your minus, supposing this is minus AU plus AE over here, right? Your U, you're going to sub in as KT minus T. Your E, going to sub in as KT minus T for the forward method. Alright, for the forward method, you're subbing as KT minus T. Alright, for the backward method, okay, I'll just copy this. I'll just go all the way here. You see, your U over here is sub in as your KT. Your E over here is sub in as KT. So for the forward, just to go back again, your forward is KT minus T. Your backward is just sub in as KT. Okay, while your trapezoidal, which is minus AU plus AE also, your U over here is going to sub in as KT. Sorry, wow, this thing is more chim. Hold on a while. You'll become more chim, seriously. This thing over here, alright, and this thing, okay? If you still remember your trapezoidal, you're taking your K minus 1. You're taking two things and then divided by 2, right? If you still remember, this is your twisting equation. Okay, this point is your K plus 1. This is your K. Okay, so when you take K and K plus 1 divided by 2, alright, you're taking the difference between the average between K and K plus 1. You're going to formulate the new point based on this average, these 2 points. Okay, this all goes back to the ancient times where we derived the trapezoidal stuff. If you don't know anything about trapezoidal, you can watch L8v2 and L8v7. Alright, I think it can fairly give you a fair good amount of trapezoidal integration part, the understanding of it. Alright, so therefore let's come back to the trapezoidal, the integration part, where in this case, this part is KT minus T, while the next one is so over here, as you can see, for the backward is over here is just one term. Inside the term, your U is your KT, your AE, which is minus AU plus A, this one. Your E is KT, your U is also KT. Okay? For the forward is KT minus, for the U is KT minus T, the E, the input is also KT minus T. Alright, the U is the output, the E is the input anyway. So therefore, over here there is two terms. It's taking KT minus T for each of this side and also KT and KT over here. So there is two terms. There is one term and two terms. The one term minus away the two terms. Something of that meaning. Alright, over here this is only one term. This one over here is only one term. The one term means that this whole thing is one term. This whole thing is one term. While over here, this is the whole thing over here includes two terms, one term and two terms. I hope you kind of get what I mean now. Alright? Or in other words, your trapezoidal rule, you can somewhat say that you're taking your forward, which is this one, minus away your backward, give you this thing. So this is your forward minus your backward, give you your trapezoidal. Alright, but there's totally no meaning. I don't know how to derive the meaning, but at least you can see in terms of the relationship, the equation. Okay, this is the particular step. For forward, backward and trapezoidal, this is the particular step that you may need to consider. Okay, this is the particular step that you may need to consider for each of them. Alright, and later on the rest of the divisions is just math only. Alright, I wish we have go through. Alright, and yeah, therefore you can, for your low pass filter, you can get your information by using forward. You can get your information by using you can get your information by using backward and trapezoidal, and we have somewhat proved to you that they are all somewhat near the same, except the point where just the step after your integration, before you integrate just the step before you integrate, and then after that you integrate already, things start to go differently. The things that you sub in is a little bit different. Okay, but so I hope that this is pretty much clear, and I shall see you in the next video for the shortcut way of things, and because later on we'll explain so see you there then.